Okay, today we're doing 9.3, which is solving quadratics by completing the square. Our learning goal for today, I will solve quadratic equations by completing the square. And also, I will solve real life problems. So the way that this is going to work is we have to flash back to when we were doing factoring and expanding, where we had something like this. Remember, when we had a plus b squared, this was a perfect square. This expanded to a squared plus 2ab plus b squared. And that's what it expanded to. So we would call this a perfect square trinomial because when it factored into something neatly like that. So completing the square is where we're given the first two terms. So we have this term and this term, but we don't have that guy. So it would be something like this. And we don't have that last term there. We need to figure out what does that last term have to be so it will factor into a perfect square like this. So that's the idea behind completing the square, and that's what we're going to be learning today. So for our first example, we're just going to go with the one that I have written here. And something that I also want you to remember, we use A and B, we use these A's and B's. They get used in a couple different ways because then we also could have this. Remember our standard form. This A and B is different from that A and B. So I know that can be a little bit confusing. This was just to show you what we're doing today. Now put that A and B designation out of your head. When you see A and B, we're talking about A is the coefficient to the quadratic term, B is the coefficient to the linear term, and C is your constant at the end in our standard form for a quadratic. So keep this in your head. So the steps for completing the square, or for figuring out what do I need for my last term there, the steps are pretty straightforward. The first thing is we identify B. B is always the coefficient of our x term. So in this case, B is 6. And then our next step is to take half of that. So half of B is 3. And then our final step is to square it. So in this case, we'll get 9. What that tells us then is our last term here has to be 9 in order for this to be a perfect square trinomial. And what that means then is I can factor this, and interestingly enough, this will factor where the second term in my factored form is this intermediate step right here, this 1/2 b. So I found what b was, I took half of it, I squared it, that told me what my last term needed to be to complete the square, and then to factor it, I used this intermediate step. It was just half of my middle term is what gets put in the parentheses when it's in factored form. So don't worry, we'll do a couple of these. Also, if you hear like random rattling behind me, I have a baby on the floor, so it's spring break, kids are home. Sorry if there are interruptions during this video. So another example. Let's do x squared plus 8x. Now, what we're doing right here is we're just learning the method. We're not actually solving an equation right now. After we do a couple more of these with learning the method, then we'll take that method and go further and solve the equation. So here we have x squared plus 8x. We're looking for the c term. So I need to take half, b then is 8, take half of b, I get 4, square that, and I get 16. So that tells me that this needs to have a plus 16 on the end in order for it to be a perfect square trinomial. So So if I have x squared plus 8x plus 16, that's then going to factor to x plus 4 squared. These are always going to work out to factor into a perfect square because that's how we picked that last term. That last term is specifically there in order to make it a perfect square. So if for some reason you can't factor it, you screwed something up. So go back and try it again. Let's do another one. This one's going to have subtraction in it. But it really follows the same method. So we have x squared minus x. It might be easiest if we think about this as x squared plus a negative x. So just changing that subtraction. Because then we follow the exact same steps. In this case though, b is negative 1. So half of b is negative 1/2. And I'm going to say for these, leave them as fractions. Don't bother turning them into decimals. So we take half of b, we have negative 1/2. Half of b squared then is negative 1/2 times negative 1/2, or positive 1/4. What are you doing down there? So that tells me that I need a positive 1/4 then tacked on the end in order to make this a perfect square. And then when I factor it, it was x squared minus x plus 1/4. When I factor this, this is going to factor into x minus 1/2 squared, or x plus a negative 1/2. You can deal with that negative either way. So this is how it's going to factor. So that's the general idea. Like I said, leave, when you cut things in half, just leave it as a fraction. You know, if this were a 7, I would leave this as 7/2 and then square it to be 49/4. It's just easier if you leave the fractions in there, and that way you don't need to get your calculator out just to do a little arithmetic. So that's the general idea behind what we're doing. Okay, now that you know the method behind completing the square, let's use it. X squared minus 6x equals 27. So what we're going to do is we're going to focus on completing the square over here, which means I'm going to need to add something or subtract something. So what's going to happen is I need to figure out what b is. Oops, I'm sorry, I jumped ahead. B is negative 6. Half of b is negative 3. Half of b squared is positive 9. You're always going to be adding. I don't know why I said subtract. So you're going to be adding a 9 over here, which means that on the right-hand side, instead of just having 27, you're also going to have to add 9 on that side. Because remember, in math, we have to keep things balanced. If I add 9 to the left-hand side, I have to add 9 to the right-hand side, or otherwise it won't be balanced anymore. We can't just pick a random number and stick it on one side without doing it to the other. So now that I've completed the square on the left-hand side, I can factor it because it's a perfect trinomial. So this will be, let's see, negative 3. So x minus 3 squared is how this factors. And over here on this side, I have 29 plus 3, or I'm sorry, 20, what am I talking about? 27 plus 9 is 36. I just got distracted again. That's why you shouldn't do this with babies around. So what we're going to do then is we are just going to use our method from section 2, which was solving taking square roots, because I have x minus 3 squared equals 36. I take the square root of each side, and I'll get x minus 3 equals plus or minus 6. So that tells me that x minus 3 equals a positive 6, or x minus 3 equals a negative 6. And then I just proceed, and I get x equals 9, or x equals negative 3. So that is how I'm going to use completing the square to solve. This was the most basic case, so of course our next example is going to take it one step further. Okay, so for our next example, now we have a c term on the left-hand side. So what we have to do is we're actually going to add 5 in this case to each side. We want to get rid of that c term. So if I add 5 here, I'm subtracting 5 and adding 5, I get 0. So I'm also going to add 5 here. And the reason I'm doing that is I only want the x squared term and the x term on one side. I can complete the square if I have a c term over here, but it's a lot easier to make mistakes that way. So I would prefer that you do what I'm doing here, where you move all of the constants to one side of the equation and you keep the x terms on the other. So if I add 5 to each side, over here I'm left with x squared plus 4x, and I'm going to leave room for when I complete the square. And on this side, I'm left with 12. So then my next step is going to be to figure out what I have to add here. So in this case, b is 4, half of b is, half of b is 2, half of b squared is 4. So that means I'm adding 4 here. If I add 4 on the left-hand side, I have to add 4 on the right-hand side. So this is x squared plus 4x plus 4, and that equals 16. Now I want to factor this to make it easier to solve. So this will be x plus, there's my 2. So x plus 2 squared equals 16. Hi, Matthew. Then I'm going to take the square root of each side. So I get x plus 2 equals plus or minus 4. So x plus 2 equals 4, or x plus 2 equals negative 4. Those are the two equations that will give me my solutions. Subtract 2 from each side and I get x equals 2. Subtract 2 from each side over here, I get x equals negative 6. So these are my two solutions. Remember, when you're solving equations, you should always go back and check. So put in 2, 2 squared is 4, 4 times 2 is 8, so that's 12 minus 5, and we get 7. We could put in negative 6, so that would be 36 minus 24, I think. Yep, 36 minus 24 is going to give me 12, minus 5 is 7. So both of those solutions work. So that is how we're going to do this. Okay, here is our final problem. It's a word problem, but it also incorporates one extra step that we didn't have to do before. So situation, you're throwing a stone with an upward velocity of 48 feet per second from a height of 16 feet. The function h equals negative 16t squared plus 48t plus 16 gives the height h of the stone after t seconds. When does the stone hit the ground? So here's the scenario. You're like standing on the roof of your house, which I do not think that you should do. But for whatever reason, you're on the roof of your house. You're 16 feet above the ground. And you throw a rock up in the air, and then it comes back down. And you throw it up with an initial velocity of 48 feet per second. So that's what's happening. So the rock is going up and coming back down. Again, don't try this at home. So this is our function. And remember, h is how high the stone is after t seconds. So if you put in 1 for t, that would tell you how high the stone was at 1 second. If you put in 4 for t, it would tell you how high the stone is after 4 seconds. So we want to know when the stone hits the ground. Another way of thinking about that is when our height is 0, because the height is 0 when you hit the ground. So we want to know, when does this thing, oops, I forgot my negative. Negative 16t squared plus 48t plus 16. When does that equal 0? We're going to do this by completing the square, but notice we have a coefficient on our t squared term, or our x squared term. So we can't really do what we were doing before. The first thing we have to do is we have to factor out a negative 16t. So this is just like what you did in the factoring section, where you divided out any common terms if you could. So I'm going to take out a negative 16 from each term. This is one way to show that, which means I also have to divide the left-hand side by negative 16. Luckily, the left-hand side equals 0, so that's easy. So when I factor out that negative 16, I get negative 16t squared divided by negative 16, which is t squared. 48 divided by negative 16 is negative 3t, and 16 divided by negative 16 is negative 1. So this is actually what I'm going to do for completing the square. Oops, sorry, I just bumped the table. So the next step is going to be going back to the completing the square things that we've done before, where I want just my t squared and my t term over here. So I'm going to add 1 to each side first. So I get 1 equals t squared minus 3t. Now I identify b, which is negative 3. I take half of it, which is negative 3 halves, and I square that. 3 times 3 is 9, 2 times 2 is 4, so I get 9 fourths. So I have t squared minus 3t, and then I add 9 fourths. If I add 9 fourths over here, though, this is going to be 1 plus 9 fourths. 1 is 4 over 4, so really I have 13 fourths on the left, and I have t squared minus 3t plus 9 fourths on the right. So from here, this will factor to t minus 3 halves squared, oops, and that's 13 fourths. Come here. So then, I just follow my previous steps. I take the square root of each side. So the square root of 13 over 4 equals t minus 3 halves. And from here, I actually am going to want to get my calculator out because this is a real life problem. If I add 3 halves to each side, so this is 3 halves plus or minus the square root of 13 over 4. This is a real life problem. I don't want a square root in my answer. That doesn't actually make any sense at all. So I get my calculator out and I'll do 3 halves plus the square root of 13 divided by 4. Oh, I have an extra parenthesis in there I don't need. So when I add, I get about 3.3. Now, what I can do, if you have a calculator like this, I can do second and then the enter button, and it pulls up that same equation that I just had, and I just change that to subtracting. And I push enter, and I get negative 0.3. Now, I think back to my situation though. Does it make any sense to have negative time? No, it doesn't. So that means my only solution really is t equals 3.3 seconds. So there's only one solution here. So that is how I'm going to solve these real world problems. So that was a lot of steps, but hopefully you were able to follow along with it. Your homework assignment is, give me one moment. Homework assignment starts on page 472. You're going to do numbers 1, 2, 12 through 24 even. I have another crying kid. Hold on. 26 to 36. Sorry about all the interruptions. I will make sure that they're gone for the next video. But have a great afternoon.